Hi, my name is Kim Cobb. I'm professor of Earth and Atmospheric Sciences here at Georgia Tech and the director of our Global Change program. And I'm here today to bring you up to speed on climate change and its solutions and how the carbon reduction challenge fits into those solutions. So let's get right into it with some of my slides. And this is just to remind me that you can find me on Twitter at Corals and Caves, and you can always drop me an email if you have any questions about the content that I'm presenting today. So I think most of you have probably heard already about the greenhouse effect, and so we're going to be pretty quick here. There are a number of gases that we are emitting into the atmosphere, which are trapping the outgoing heat that our planet is trying to radiate into space, and it's trapping those in our atmosphere and warming the surface of our planet quite significantly, about 1 degree Celsius since the pre-industrial. The greenhouse gas levels in the atmosphere are the highest in human history. They are right now at about 417 parts per million. That's the unit of measure. And they're going up every year, as illustrated by this graph of the whole history of the CO2 concentrations at Mauna Loa Observatory in Hawaii. And it's been about 315 parts per million when this record began in 1958. And here we are at the 417, going up about 3 parts per million every year. And these concentrations also are astounding in the context of the last several million years of Earth's history, which has experienced variations in carbon dioxide in the atmosphere in line with the ice ages that come and go every 100,000 years or so. And where we are today is clearly way off the baseline of natural variability. Turning to temperature here, this is a record of instrumental temperatures, of surface temperature across the globe since about 1880 or so up to the last year of the record, 2019, which was the second warmest year on record. 2016 still holds the record of the warmest year in this instrumental record of climate. And what you can see here is it's not nearly as smooth as the CO2 curve I just showed you, but obviously it is dramatically warming over the last several decades, and the sum total of the warming that we have experienced is roughly 1 degree or 1.1 degrees Celsius, depending on how you calculate it. Now, what's causing that warming? We can actually turn to some very sophisticated methods of whodunit, or some fingerprinting, as we like to call it in climate science, to try to help us understand the causes that have driven the most recent rise in temperature over the late 20th century. And what we see here is the analysis of the role for volcanic and solar forcing over the 20th century, showing us that they've contributed almost no warming, especially over the last late 20th century. Conversely, when we look at the culprits more in detail, including all of the effects that humans have on our climate system, which include greenhouse gases, but as you can see here, also include the emission of aerosols, which have a reflective effect on our planet, and also land changes with the vast clearing of forests actually altering what our planet looks like from space, and also in net serving to increase the reflectivity of our planet. But here you can clearly see that it's the greenhouse gases that have driven that very accelerated warming over the late 20th century. When we go back and look at what we know about temperature over the last 1,000 years, we can actually put the 20th century temperature rise into a longer term context, which is so very important. This is the work that I do in my lab, looking at how we can use past records of temperature change to understand how unusual today's temperature changes are, and of course, how we might understand our future better by looking at our past. And so here you can see the instrumental temperature record at the far right, that black curve, that little jog to higher temperatures over the baseline of last millennium climate change. And here you can see just how unprecedented the recent warming has been since about 1950 or so. And this is reported in the Intergovernmental Panel on Climate Change third assessment report that was reported in 2007 and has been revisited ever since. Now, one of the effects of the warming that we have seen in the last several decades have been something that strikes very close to my own heart. given that I use corals as an archive of past ocean temperatures for my research, this is documenting one of the second ever global scale coral bleaching and mortality events that swept our oceans in 2016 and really caused a devastating mass mortality event on the island that I've been working on for 20 years. Much more recently, we've heard reports from the Great Barrier Reef of extensive coral bleaching and some coral mortality even just earlier this year. And of course, that is the austral summer down there, and something that we know has caused a widespread coral bleaching event that has continued across the Great Barrier Reef, becoming the third such event in 5 years on the Great Barrier Reef. Also in Australia, of course, we had to watch helplessly as the headlines coming out of Australia for the summer fire season down there, just devastating in terms of its impacts on wildlife, its impacts on communities that may never be the same with this devastating record-breaking set of wildfires that they had. And my colleague Ed Hopkins reminds us of how unusual the temperatures were in Australia during these wildfires here, illustrating that how they just leapt off of the baseline in 2019. That was definitely a primary cause to the extent of wildfires that Australia experienced during their fire season. And his point here is that the projections for the next decades are very much in line with having that not just be an extra warm year, but having those kind of temperatures be a normal year within several decades. So kind of a big wake-up call for where wildfire-prone areas like Australia are heading. And it's not just Australia, of course. We've been experiencing very dramatic heat extremes over the United States in the recent past. I'm sure this has not escaped you living in a city like Atlanta here. And this is just fully expected as we don't break cold records anymore. Now we're breaking hot records, and we're breaking them repeatedly across the nation. And one of the things that is contributing to is an increase in wildfires in California, for example. Heat is linked to reductions of soil moisture. It is linked to reductions of vegetative moisture. And that makes for a very prime condition for the extensive wildfires that we had every single year now for quite some time in California. This is an image just last fall from California's extensive wildfire season. And it's not just wildfires and coral bleaching that is really evident in the climate records today. This is a compilation that NOAA makes every year of the billion-dollar damage from related climate and weather events here in the United States. And you can break it down by the different colors showing the different types of weather disasters. But here you can see a clear uptick in the number of devastating extremes that we have experienced over the last several decades relative to earlier periods. And we expect this to get worse with climate change as well, not a surprise. One of the things that's growing to be a massive problem along the coast is sea level rise. And we have here in Georgia a very vulnerable low-lying coastline, but much of the East Coast is similar. And so this is just, I think, a clear illustration of what has happened in the satellite record of sea level over the last several decades now. And this has amounted to sea level rise rates of about 3 millimeters per year on average. Going forward, we expect this to accelerate as warming accelerates, but also as global ice sheets melt. And the National Climate Assessment provides our best guess at where that sea level rise is going to land in several decades. Their projections of sea level rise by 2100 amounting to 1 to 4 feet likely. That's a 68% likelihood by 2100. And then they're very careful to note that up to 10 feet of sea level rise is possible by 2100, although they admit it's very difficult to assess with our current data sets and models. One of the things that we have to think about in terms of the uncertainty of future climate change is what we will do in terms of our emissions choices. Higher emission scenarios will take us towards further climate damages, closer to those 10 feet numbers, and strict controls on international emissions will, of course, keep the warming to a lower level and keep all those related package of climate damages far less. So that's the choices that we have to make, and that's a good amount of what is baked into the uncertainties of future climate change that I just quoted from the National Climate Assessment. Is not our understanding of the climate system, it's our poor understanding of the choices that we will make over these next decades. And I wanted to highlight the vulnerability of the Georgia coastline in particular, already seeing climate change baked into sea level rise and floods down on the Georgia coast. Proud to be one of the lead researchers for a project called Smart Sea Level Sensors. I put the hyperlink down there in case you're interested in checking out how Georgia Tech is partnering with communities down there to try to adapt and provide some tools for communities to prepare for sea level rise today and decades to come. Of course, it's not just sea level rise that is threatening our coastlines, but we have dramatic changes in the cryosphere or ice dynamics in coverage on our planet since the last decades. We've all heard the headlines of record Arctic sea ice minimum again and again and again. This is in steep decline and will certainly rework the Arctic ecosystem in polar environments for decades to come. One of the things that I think it's important to remember about climate change is that we have extremely important decisions to make over the next 10 or 20 years, decisions that will determine the trajectory of climate change for millennia to come. This is a paper that digs into this concept using a climate model to illustrate this point. So I can refer you to that, but suffice it to say that this trajectory shown here are showing millennia and millennia and millennia of rising sea levels based on the decisions that we might make over the next several decades. So that's something that climate scientists refer to as climate commitment, this idea that we can lock in so much climate change that will proceed for a very, very long time as the system comes into equilibrium, or we could begin to turn the corner on this and begin to slow those accelerations as they get up to ramping up seriously this century. And so this is both a blessing and a curse for our generation, of course, and yours as well. This is going to go down on our watch. We're going to be dictating what this planet looks like for millennia to come. And it's going to be us that decides the trajectory of emissions that's going to determine the higher rates of change or the lower rates of change. So this is a great opportunity, I think. I think we are extremely lucky to be alive right now, to be involved in facing the challenge of one of the most serious challenges in human history. And where are these greenhouse gases coming and how can we begin to turn the corner on this? I want to highlight the amazing work of Project Drawdown in inventorying the global solution set that we have at our fingertips, and in this case, helping us to visualize where these greenhouse gases are coming from. I'm not going to belabor this point too much, but suffice it to say there are transportation sources, there are electricity grid sources, there are industrial sources, and there are agricultural sources. One of the things that they do in Project Drawdown is break these down into quite a fine level of detail and then show us how some of the tools that we already have, solar panels, electric cars, reducing food waste, educating women and girls, can really help us turn these knobs systematically down and close the gap between what we are emitting into our planet and what is being drawn back down by photosynthesis every year. One of the things I'm excited to be participating in here in Georgia is a project called Drawdown Georgia. And this is a photo of the entire research team here in the Candida building, talking about what we could do to accelerate our progress. Our goal is to map the road to carbon neutrality in Georgia by 2030. Quite an ambitious goal, but I'm happy to say we have identified 20 top solutions to make that happen. I will refer you to our website for more details. Now to the carbon reduction challenge. What can an individual set of students do to make a significant dent into this problem? Well, I am so proud and humbled to say that over the last 10 years, cohorts of students who have participated in the Carbon Reduction Challenge have reduced millions upon millions of pounds of carbon dioxide and avoided it from ever being emitting. And one of the ways that they've accomplished this is by partnering with local organizations in most cases, although sometimes they're very far away as well, to design and implement a large-scale energy efficiency project. This project saves carbon dioxide to the tune of millions of pounds of CO2 per year, and it typically also delivers significant cost savings to the partnering organization, which provides a great incentive to do the right thing and reduce emissions dramatically. Now, for those of you who don't understand how much 12 million pounds, let's say, of carbon dioxide is, that is equivalent to running 34 homes fully on solar for about 20 years. So that is a lot. That is not a trivial amount of CO2. It's larger than all of my lifetime of emissions put together. So that is a major accomplishment and something that I am always amazed at in terms of how the students are able to identify these sources of waste and reduce them. What are the students doing to accomplish such an amazing reduction? Some of the projects that I want to list here refer to some of those strategies. In one case in 2017, a group of students that was working with SunTrust worked to change the default setting on the rental car program in SunTrust from intermediate size to economy size and quantified the associated carbon reduction savings as 1.5 million pounds of CO2. Just earlier this year, we had a project working to retrofit parking lot lights at the Waffle House from energy gulping bulbs to energy sipping bulbs, LEDs in this case, saving 2 million pounds of CO2 in the process. And last but not least, through the Catholic Relief Services, a group of students worked to design a fleet modernization plan for that organization and netted almost 7 million pounds of carbon dioxide savings. And I think the only question that you should be asking yourself right now is, what will you accomplish? Thank you so much.